Determine the limit as x approaches positive infinity and as x approaches negative infinity of the cubed root of 8x cubed minus 3x squared plus 2 divided by 9 minus x. The highest power term in the numerator is the cubed root of 8x cubed. The highest power term in the denominator is negative x. The cubed root of 8 is a 2. The cubed root of x cubed is x. The x's can cancel, leaving a 2 over a negative 1. A positive over a negative is a negative, and 2 divided by 1 will be a 2. Therefore, the limit as x approaches positive infinity will equal negative 2, and the limit as x approaches negative infinity will also equal negative 2. Now let's show that this is the case. Starting with the limit as x approaches positive infinity of the cubed root of 8x cubed minus 3x squared plus 2 divided by 9 minus x. The first thing to do is plug an infinity in for all x's. Only the highest power term in the numerator and denominator will matter here. In the numerator, positive infinity cubed is positive infinity times 8 is still positive infinity, and the cubed root of positive infinity is positive infinity. In the denominator, we'll plug a positive infinity in for x times a negative will be negative infinity. So we have the positive infinity over negative infinity result. And we have the infinity over infinity indeterminate form here. We will need to rework this. And it is reworked by dividing both the numerator and the denominator by the highest power of x in the denominator. That will be x to the first power. So we will divide the entire cube root in the numerator by x to the first power, and each term in the denominator also by x to the first power. In the numerator, the cube root can extend over the x, by writing it as x cubed, because the cube root of x cubed is x. In the denominator, the first term does not have any x's to cancel, and it will remain as 9 over x. The second term, the x's can cancel, and it will become minus 1. In the numerator, each term can be written over x cubed and we will leave the denominator alone. The first term in the numerator, the x cubes fully cancel, leaving an 8. In the second term, 2 x's in the denominator will cancel the 2 x's in the numerator, leaving a minus 3 over x. The third term has no x's that can cancel. It will remain as a positive 2 over x cubed. All terms that are a constant divided by x to a positive power will go to 0 as x approaches positive infinity. The result will be the cubed root of 8 divided by -1. The cubed root of 8 is a 2 divided by -1. Positive over negative is negative. 2 over 1 is a 2. Now to work out the limit as x approaches -infinity of the cubed root of 8x cubed minus 3x squared plus 2 divided by 9 minus x. The first thing to do is plug -infinity in for each of the x's. Only the highest power term in the numerator and denominator will matter here. In the numerator, -infinity cubed is -infinity times an 8 will still be -infinity, and the cubed root of -infinity will be -infinity. In the denominator, negative times -infinity will be positive infinity. And we have the infinity over infinity indeterminate form here. We will have to rework this, and it will be reworked by dividing the numerator and denominator by the highest power of x in the denominator. That's x to the first power. However, since x is approaching -infinity, and the highest power term in either the numerator or denominator is inside of a root, that's happening here in the numerator, instead of dividing by x to the first power, we will divide by -x to the first power. So we will divide the entire cubed root in the numerator by -x to the first power, and then each term in the denominator by -x to the first power. In the numerator, the cubed root can extend over the -x, by writing it as -x cubed, because the cubed root of -x cubed will be -x. In the denominator, the first term is positive over negative. That's negative. There are no x's that will cancel, so it will remain as a 9 over x. In the second term, negative over negative will cancel to become positive, and x over x will cancel to be a 1. In the numerator, each term can be put over -x quantity cubed. Negative cubed is negative, and then x cubed. So each term can be put over -x cubed. We will leave the denominator as is. In the numerator, the first term, the x cubes can cancel. Positive divided by negative is negative, 8 divided by 1 will be 8. In the second term, the negatives will cancel. It will become positive, and 2 of the x's in the denominator can cancel with the 2 x's in the numerator, leaving a 3 over x. The third term, positive over negative, will be negative. There are no x's to cancel. It will remain as 2 over x cubed. Over the denominator. Each term that is a constant divided by x to a positive power will go to 0 as x approaches negative infinity. The result of this will be the cube root of negative 8 divided by 1. The cube root of negative 8 is negative 2 divided by 1, and any number divided by 1 will be itself. So it results also in negative 2. And there's the results of the two different limits.